Let me clear out the confusion that I made in the previous lecture about the active and deforming. If we go into our RPD configure, and here you can see previously we have these two options. We have the animated and we have the deforming. So let's see what is the difference is in between the animated and the deforming, and let's also see that when we are going to, let's say, not create an attribute name. Right now we have created an in name and we are using the sphere, but let's say if I'm not going to collect the name, and right now we are not creating the name. If I were to middle mouse button, and here you can see we do not have the name. But if we go into the RBD configure, and if I were to middle mouse button, and here you can see we have our one pack geometry also have the name attribute. So if the name attribute is not present in your input geometry, this RBD configure node will create a name attribute for us. If we go in here, and here you can see we have the attributes and name prefix, and it's using the piece, which means that if the name is not there, it will just create the name and with the prefix of piece. Right now we have the one piece, we have the single connected piece of geometry. We should see the piece 0. I can confirm, go into the RPD configure, and in here we have the name onto the point attribute. So let's go into the geometry spreadsheet, and let me enable my point attribute, and here you can see we have the name attribute and it says piece 0. So we have the name attribute present in here, and we were using the Voronoi fracture to fracture our geometry. And if I enable the parameter, and here you can see this Voronoi fracture node, it is to creating an a piece prefix. It is also creating the name attribute. If I were to middle mouse button, and here you can see we do have the name attribute, and it is also using the piece prefix, which means that if I enable the primitive attribute, because it is creating a primitive attribute, here you can see we have the name and it start with piece 0, and it is starting with piece, and it will assign 0, 1, 2, 3 all of these pieces and a unique number in front of them. And after the RBD configure, it will transfer this our name attribute onto the point, and now we can see on our point level. Let's go into the points. I can see all of our name attribute. We have the piece 0, 1, 2, 3 all of the name attribute. Because of that, because we were using the same name, here as you can see onto our this piece attribute, here we have the name, it is set to piece 0, and we also have the piece 0 in here as well. So we are using the same name on both of these our stream, and that is what causing the confusion onto our this bullet solver, and I forgot to actually rename this. We can fix this by either creating our own name attribute that we just did in previously. I'm going to just connect this in here. Now that we are creating the name and we are adding the name in here sphere, and now this RBD configure node will use the name attribute because the name as attribute is present, and it will use the name to pack our geometry. So I can go into the RBD configure and I can confirm, go into the geometry spreadsheet, and here you can see now our name is set to sphere. And if the name is not there, if I shake this off, and here you can see it is saying piece 0 because it is automatically assigning the name with this piece prefix. That is what causing the problem. So the name attribute is present, and make sure that do not use the same name in both of your side in multiple times, because that will cause the confusion in this solver, because solver recognize all of these pieces with their name, so they must be unique. We have the option that is active and animated, and active mean that that if I were to disable the animated, now that we have solved the problem of the naming by creating our own name attribute. And by the way, we could have also solved this if I were to shake this node off. As you can see, we are using the same piece prefix that is utilizing the Voronoi. I can just go in here, either change the piece prefix in here. Let's say I'm going to say piece underscore vol. I'm just changing the prefix, which means that we are adding the piece vol and then the number. So if I go into the RPD configure, and geometry spreadsheet, and here you can see we have the piece and wall and the number 0, 1, 2, 3. We have updated our prefix, which means now this RBD configure is still using its own piece prefix. So now it should have a piece 0 and it is using this piece wall. Now we have unique name attributes. So now we do not need to actually create this attribute create, and this automatic attribute creation will work. Now if I go into the scene view again and let me enable by bullet solver and let's hit play. And as you know, we have disabled the animation option. Activate means that the forces has no effect, and to actually import our animation we need to enable the animated and change this to 1 and hit play, and we have our animation back. The deforming mean that right now here you can see, because we are working with 1 point, this sphere is a 1 point. We are actually animating this 1 point, and that is why this animated is working. If I were to change this to, let's say, regular mesh, I'm going to change this to polygons, and here you can see now we have all of these primitive, we have multiple points. And now because we are still using the same transform, but what this transform is actually doing, it's actually moving these points. We are moving all of these points. This transform is moving them, which means that we have our deforming geometry. So now if I were to do the same thing onto the RBD configure, here you can see we have the animated enable. Now this animation won't be imported. I can go into the RBD bullet solver and hit play, and here you can see animation is not there. And that is because now we have the deforming geometry, because we are working with actual points, our actual geometry, and we are using the transform node and it is deforming them. We need to go into the RBD configure. In here we say that animation is not there. I'm going to just change this to animated, and I'm going to say deforming, because right now we are basically deforming these points, and now it will work. Let's go into the RBD bullet solver and hit play, and here you can see now we have our deformation back. And to actually make this work, this animation work, either we can change this to 1 point. I can go into the primitive, and in here now, because we are working with 1 point and this transform node is just moving this single point, and the RBD configure node will recognize this as an animation. I can just enable the animated and it will be imported in our simulation network. And to actually take the benefit of the animated, and later I will explain why the animated is beneficial, but if you are going to pack our geometry right now here onto the RBD configure, this node is packing our geometry, and I'm going to do the same thing onto this sphere. I'm going to change this to polygons. Now we are working with all of these points. We have our original mesh back. I'm not going to use the transform node to transform my all of these points, but instead I'm going to move this my packed geometry, because after we have packed our geometry, and right now we only have 1 point. We are only working with 1 point. If I were to middle mouse button, and here you can see we have 1 point. And now if I were to animate this 1 point, and because right now we have first packed our geometry and then we are transforming this, now this animated will work. So in here same thing, animated is enabled, which means now if I go into the bullet solver and hit play, and here you can see we have our animation back with the animated, even though we have all of these, because now this transform node is moving this single point. And that works because onto the RBD configure, when we are going to create our pack geometry, when we are using this pack will create a single point. As you know, if I create an extract all point, I'm going to say extract all points and connect this in here, and here we have the one single point, and this single point has information. It has the rotation information and orientation and the translation information, and all of these information are stored in what called the intrinsic attribute, and I can view them. If I go into the geometry spreadsheet, here you can see all of these attribute, because right now we are in the points, we need to go into the RPD configure to actually view this as an a primitive. And here you can see packed, we have the packed primitive. We still have one point, but it is an event packed primitive. And onto the primitive, we have some intrinsic attribute, and I can view them by going on to my primitive attributes. And in here, we have the option to view the intrinsics. And if I view this, and here you can see we have our intrinsic attributes. We have the packed full transform. And if I enable this, and here you will see that it is creating this an a 4x5 transform matrix, and this transform matrix is what storing the position information of our sphere of our these points, because right now our point is located at the origin. So we have this 0 1, all of the default full transform matrix. It knows where our this original sphere is. It does not have to be sphere. I can create a rubber toy geometry in here, and here we have the rubber toy, and I can connect this in here. Now our rubber toy is a packed primitive, and now I can go into the geometry spreadsheet and primitive, and same thing. I'm going to first we need to click on this RPD configure to have access. And here you can see right now we are creating 9 packed fragments, as you know, because we have multiple connected pieces of geometry. If I were to enable the selection and 3D connectivity, you see we have multiple connected pieces of geometry, and this RBD configure will look for the connectivity and create unique packed primitive. And here you can see we have multiple packed primitive. We have the 10 packed primitive. Let's go into the geometry spreadsheet, and that is why we see multiple of these points. All of these points have their own full transform matrix, all of these matrix, and that is what storing the position information. We are scattering the points, we are adding the points for each of our connected object, and I can view them by extract all points. And here you can see we have these points for our these connected pieces of geometry. Here I am creating one point that is defining our this piece, and another point for that is defining our that piece, and we have all of these points, and they are what storing all of our position and orientation information. And Houdini knows how to draw our geometry, and that's how these packed primitives are working. When we are going to pack our geometry, right now we have packed our geometry, and we are going to transform our packed geometry. First we have packed them, and now we are transforming our packed geometry. And by doing so, we are updating our transform matrix. If I go into the geometry spreadsheet, here you can see we have some values updating. And if I were to hit play, and here you can see all of these values are changing. And that is because we have the animation that this transform node is changing this packed transform position. And because we have updated this transform this position, and that is why we have this moving animation. And as you know, Houdini knows how to draw your object, and that is why after the RBD configure we have the animated option working, because now we are just animating this transform matrix. We need to click on this transform to actually view this, and here you can see this transform matrices has been updated. Before that, if you add a transform in here, as you can see we still have the animation, but right now we are packing our original geometry. Now we shouldn't see this pack transform updates. If I go into the RBD configure, go into the geometry spreadsheet, here you can see if I scrub, my pack transform are not updating because we are packing after we have animation, and it will always by default stay onto its default location. And that is why this RBD configure, this animation option is looking for these packed full transform to update. Because there is no update, or this transform matrix is not updating, that's why this animation is not being imported. And here you can see it is not being imported because of the order. And let me disconnect this and connect this after that. Now that we are moving our packed fragments, Now we should see the animation. Let's go into the bullet solver, and here as you can see we have our animation back. And the difference between the deforming is, if I let me move the rubber toy geometry, and right now it is throwing an error. If I were to deform this right now, if you were to add a transform node in here, I'm going to just connect this transform node. It is actually deforming our points as well. And same thing, I can add a noise based transformation by adding the mountain node. So in here I'm going to type this and add this. Let's animate these points, and I'm going to change the range value to positive, and let's increase the amplitude, and maybe let's enable the animation option so that we have the animation. And now here as you can see we have our points and they are deforming, which means if I were to connect this in here, and I'm going to visualize this sphere, and let's template this geometry. I'm going to just displace this in here, and I'm going to place this in somewhere so that we do not have collision at the very start. And now I think we are getting the collision. Okay, that is fine. Now you know that these points are deforming. Onto the RBD configure, to import these animation, this animated won't work because we are packing onto single point and we have all of these deformation onto this level. If I go into the bullet solver and let's hit play, and here as you can see we do not have animation back. And if I go into the RBD configure, and we need to enable the deforming, and we actually do not need to enable the animated because we are adding the deformation. Now the deforming is enabled. Now our solver will look for the deformation. Let's hit play, and here as you can see we have our deformation back, and we should see some collision. And right now here as you can see we have the collision. I'm going to just increase the amplitude value so that we have some higher collision, and let's hit play. And here as you can see this animation has been imported and it is also interacting. You should only use the deforming option when necessary, and that is because it is computationally expensive. And why it is computationally expensive? And that is because we are updating our collision shape geometry every frame, because the solver is saying that this collision shape is changing. In that case it is changing, and I can also visualize my collision geometry. Let's go into the RBD bullet solver. I can go into the visualization, and in here we have the show collision shape. Let's enable this. We are visualizing this as a wireframe. I can enable this show collision shape. Let me hit rewind and hit play, and here as you can see we have this collision and it is changing. We are updating this collision shape geometry every frame. This convex hull is changing. That is why it is computationally expensive, because this solver has to recalculate its convex hull, its collision geometry every frame. In the case of the basic transformation, because in this case we are actually using the mountain node to add the deformation, in this case it is essential to use the deforming because there is deformation. But in the case of simple transform animation, if I were to remove the mountain node, in here in the transform, if we were going to use this transform, we actually do not need to create an animated. I'm going to add a key. I need to move this in here because I'm going to just move this in here, add a key, go back at the very first frame, and let's place this somewhere around here, and we have some animation. Now in the case of this simple transform, we actually do not need to create the deforming. Even though this deforming is working, that is not the efficient way, because we are calculating this collision shape every frame. So we can actually save our calculation by not using the deforming. but we can use the animated. And to actually use the animated, you must need to add the animation when you have packed your geometry. In here we have the packed geometry, and now I can add the transformation. And now our this pack transform will going to be updated. We go in here, and here as you can see our this transform matrix has been updated, which means our this solver will recognize this. And let's hit play, and here we have our animated geometry back. So that is the difference between the active and the deforming of our these geometry is. Let me go into the RPD configure. That is the difference between the animated and deforming. I hope that have cleared all of your confusion.